Welcome back. We're about to talk about one of the more important concepts of this course because it links to so many things in the near and distant future. Adding and subtracting fractions. A lot of people often memorize how to do it. We're going to also take a look at how it actually works, try to make a bit more sense of it so that we can increase our depth on what's going on. What you'll find is that's going to help you a lot when we try to apply it in other situations like, I don't know, percents, conversions, algebra, and beyond. I'm going to start off with really simple numbers so that we can get a clear picture of what's happening. So we're going to add a quarter and a quarter. This is probably the easiest fraction adding that we can do because we don't need to make common denominators. We don't need to change or convert anything, well, except at the end. So let's go ahead and try to understand what's happening when we're adding these. So what you see is we've got two shapes down here that are cut into four parts. Each of them we've got one out of a possible four parts. That's what the fraction means, right? And when we go to combine them, right, we're combining the parts, we're adding the parts together, but we're talking about a shape that's been cut into four. So we've got 1 out of 4, or a quarter, and we add another 1 out of 4, and clearly what we get is 2 out of the possible 4 parts, right? So notice the bottom number doesn't change because we're talking about how many cuts or how many divisions there are of this shape, right? It's cut into 4 parts. We've got 2 of them. What you'll also notice is that 2 quarters looks very much like this shape here, which, sorry, it's very difficult to draw these shapes on this type of screen, but anyway, could also be seen as 1/2, right? So there's the addition, there's the logic behind why you add the tops but not the bottoms, and also how you convert it at the end. The good news is subtraction is closely related to adding, so we don't actually have to add any additional skills here. We can just continue with the same concept. We've got a piece cut out of 4, we've got 3 out of that 4, and we've got another piece cut out of 4 where we have 1. We're going to subtract a quarter from 3 quarters, and we'll be left with 2 quarters, which, as we showed before, 2 quarters can be seen more simply, or in a simplified manner, as a half in its lowest term. Just a reminder, we get that half by dividing the top and the bottom by 2. That's the greatest common factor, the largest thing that will divide into both. As we move things up by 1 degree of difficulty, we now look at fractions with different numbers on the bottom. These are also called denominators. So when trying to add fractions with different denominators, what we need to do is we need to logically figure out a way to get these shapes cut into the same number of pieces so that we can add them. Because right now, adding, here, let's go like this, adding this quarter part with this half part, well, how are we going to do that? So these numbers are easy enough, you might be able to do it in your head, but logically it's probably best if we can split these shapes into the same number of pieces. Okay, so on the right we had a quarter, on the left we've got a half, right? So if we were to divide that up, again, those are 4 equal pieces on both sides there, right? And what that does is convert the half into 2 quarters. So let's just take a look at how that happens. What we do is we figure out, what did I have to multiply 2 by in order to get up to 4? All right, so we're going to multiply that number by 2, and if we do it to the bottom, we have to do it to the top. So what we end up with is 2 quarters plus 1 quarter, and just as we've been doing before, we can just add the top, and the bottom tells us how many pieces it's out of. All right, so we'll look at an example with subtraction, and we're also looking at an example where we're going to have to multiply both fractions in order to get shapes that are cut into the same number of pieces. Now, I'll go through this kind of the long way. Here's the long form of what we're doing. We're finding the lowest common multiple, the lowest thing both 3 and 5 will multiply to be. So 3, 6, 9, 12, 15, 18, 21, and so on. Then we've got 5, 10, 15, 20, and we're looking for a match. The lowest number that matches in both of these lists is 15. And so what we need to do now is make both of our fractions out of 15. So in the next step, it's going to look like this. And in order to, we've covered equivalent fractions. In order to make that happen, we say, well, what do I have to multiply this number 3 by? Well, I have to multiply it by 5, so I better do that to the top as well. So we get 10 out of 15. On the bottom, 5, I have to multiply by 3 to get 15. There we go. And we've made two equivalent fractions. You can see how much I'm depending on memorization of multiplication tables to do this, right? It's essential for a lot of the work that we do in fractions. So anyway, as we continue, we now have two new fractions that hold the same value as the originals. They still, if you divided them on a calculator, they would still equal the same amount. They've now been cut into the same number of pieces, so we can do the subtraction. We subtract the tops. 10 minus 3 is 7, and we don't subtract the bottoms. That's how many pieces the shape has been cut into, so we're left with 7 out of 15. You'll notice if I just go back over here, obviously you can't just go 2 minus 1 and 3 minus 5. That just gives you numbers that have no meaning in this case. Next we look at this is the essential piece to this chapter. You may have a different way of doing it. I'd like you to try and understand the way that I'm doing it here. I learned it from some tradespeople who have to add inches and feet and parts of inches really quickly. It's a really efficient method, but not only that, once you get the hang of this, there's something about number sense, understanding this method I'm going to show you and what it does to boost your number sense and your comfort for working with numbers and fractions is just phenomenal for some reason. Again, I'm keeping the numbers simple just to illustrate the major point, which is going to be how to carry when we end up with an improper fraction within a mixed number. You'll see what I mean in a second. Likely the system that you learn, the system that I learned growing up as well, is that we need to convert both of these into improper fractions first. But I don't want to do that here. What I'm going to do is I'm going to look at the fraction part of each. I'm going to make an equivalent fraction, and I'm going to do the adding without converting them to improper fractions first. Again, if this is not something you've done before, I'd like you to try it this way. So a half and a quarter, what I need to do is multiply the top and bottom of this fraction on the left in order to get an equivalent fraction. So that makes 1 and, let's do this a different color, 1 and 2 over 4 plus 1 and 3 over 4. Okay, so we have our equivalent fractions. This might look strange to you, like can we actually add these numbers? Well, yeah, let's see what happens. So I'm going to start by adding the fraction parts, and then I'm going to move on to add the whole number parts. Adding the fraction 2 and 3 gets us 5 out of 4, right? And when we move on to the whole number part, 1 and 1 makes 2. Can't be that easy, can it? Yeah, actually it is. There's just one catch. You're going to notice that this probably looks really strange to you, and that's a good thing if it is, because we've got an improper fraction embedded into what we call a mixed number, and this is not something that we generally see. So what we're going to do is we're going to convert this thing. So we're just going to convert the improper fraction part, and it's going to carry up into the whole number part because there's more than one, and we're going to see what our end result is. I'm going to look at this two different ways. So first way that I'm going to look at it, we have 5 out of a possible 4. So that's more than 1, right? We've got 5 quarters. So what we do with that is, one way to do this would be to say, well, how many times does 4 go into 5? And it goes in one whole time, right? With 1 left over, and we're going to add that to the 2 whole that we already had. Okay, so what did I do? I did the conversion of 5 over 4 into this mixed number here, and I just brought the whole number 2 over. And what that gets us is as a result, well, 2 plus 1 1/4, think of that like money. If you had $2 and you add $1.25 or $1.25 more, you end up with 3 1/4. So yeah, I just add the fraction parts if both of them have fractions, and then add the whole number parts, and I end up with the result that I'm looking for. Now that may not seem easier than than converting these to improper fractions first. I just want you to trust me at this point that this is a really important mental leap for you to make, and I'm going to look at it one other way just to drive that home. So this is basically the same, just with subtle little differences. So again, we've got 2 5/4, same answer that we had above. We just need to convert it to 3 1/4 because that's what it really is. So here I'm saying 4 goes into 5 one whole time. The one whole time is larger than the fraction part, so it gets carried up into the whole numbers. So I increase that by 1. 4 went into 5 one whole time with 1 left over out of a possible 4. And there's my result. We kind of looked at this in the previous example, but I want to look at it again. I'm going to show you the way I was taught to do this, show you how inefficient that is, and show you a much quicker way to finish a question like this. Here's what I was taught, that 5 can be written as a fraction over 1. Plus we have 2 1/2 here, so I need to make this an improper fraction. 2 times 2 is 4, add 1 is 5 over 2. And then now we need to make an equivalent fraction to make these fractions out of the same number of parts. So I multiply top and bottom by 2. I end up with 10 over 2 plus 5 over 2. Gives us 15 over 2, and now I need to convert that, so 2 into 15 goes 7 times with a half left over. Right, so this is what I was taught to do. Here's a better way. If I think of this as money, $5 and $2.50, can't I just logically add these two together? Well, if I have 5 of something and 2.5 of that same thing, don't I have 7.5 of that thing? Yeah, that's what it is. I think you'll agree this is a much more efficient way of doing it and works much, much better rather than doing all the converting and so on. Where this gets a little trickier is with subtraction. So let's take a look at that now. So I find the subtraction part a little harder to explain. It's kind of like making change, I guess, is a way to look at it. But let's have a shot at this right now. So what we've got is 3 subtract 1 1/4, and again, I'd like to avoid all the extra steps of, 3 over 1, then converting 1 1/4 to an improper fraction, and so on. I'd like to directly do this subtraction. So I'm going to do it by counting up from 1 1/4 until I get to 3. And the answer will be the difference, as if I subtracted the two. So I'll think about this part. I'm at 1 1/4. How many quarters do I need to increase this by to get up to 2? All right, well, if I'm at, 1/4, I need to increase it by 3/4 to get up to the whole number 2. And then to get from the whole number 2 up to the whole number 3, I would have to add 1 more. So what our result ends up being is 1 3/4. Now let's just go through that to make sure that we understand and that this is correct. If I was to add 3/4 to 1/4, that would get me up to the whole number 2, so I had to add 1 up to that to get to the whole number 3, which is where I wanted to be. So the result is 1 3/4. So the next example involves 2 mixed numbers. This first one here is not too difficult, and then we'll look at another one where we have to do some borrowing. That's where things get interesting. So here we got 4 3/4 minus 1 1/2. Okay, so we need our common fractions in order to be able to add and subtract these. So 4 3/4 minus 1 and 2 over 4. Now what we can do here is, and it's important, we're going to subtract the fraction parts first, then subtract the whole number parts. So 3 minus 2 leaves me with 1/4. 4 minus 1 leaves me with 3. So there we are. We're left with 3 1/4. not too bad, right? Let's take a look at this next example, which requires some borrowing. All right, so we looked at this a great deal in class. I spent a fair bit of time on it to try and understand the ins and the outs of it. I'll try and replicate that here. Starting out with 4 1/4 minus 1 1/2. Okay, so in my new system, what I'm doing is creating equivalent fractions, subtracting those fractions, then moving on and subtracting the whole numbers. Okay, so let's do that. First things first, I've got a fraction out of 4, another out of 2. So top and bottom, I multiply by 2. 4 1/4 minus 1 and 2 over 4. So nothing new here so far. However, when we go to do the subtraction, my advice was that you start with the fraction part, and here's why. Okay, so when I go to subtract those, I get 1 minus 2. That gives me negative 2. Well, maybe there's a way to do these adding with negative numbers inside the fractions and that, but I haven't figured it out yet. So instead of that, what I'm going to need to do is borrow. All right, so I tried to go 1 minus 2, and I couldn't do it. So what I'm going to do now is I'm going to borrow from the larger amount, right? A whole number's greater than what you would find in a fractional part. So from that 4, I'm going to borrow from it, and we're going to end up with 3. Now, what happens in the fraction part from that borrowing? You might think that you just add 1 to there, but let me show you why that's not the case. We're dealing with quarters, right? We had 1/4. We're borrowing from this whole number over here. We're reducing it by 1 down to 3. The one that we borrowed, the one whole that we borrowed, how many quarters would that be? Because we want to put it into the quarters column. Well, 1 whole is the same as 4 quarters, right? If you divide it out, 4 divided by 4 is 1. Yeah, 1's the same thing as 4 quarters. So I'm actually adding 4 to this top part. If we were talking about eighths or sixteenths, we would add 8 or 16, right? It depends what it is. The whole number 1 can be converted to any fraction over itself, right? 8 divided by 8 is 1, 16 by 16 is 1. So we look at the number we're interested in. That's what we should be adding to the top after we borrow from here. Okay, so as we move down, we end up with 3, and 1 plus 4 is 5 over 4 minus 1 and 2 over 4. And now we'll be able to finish our subtraction because we're not going to end up with a negative number. So 5 minus 2 leaves us with 3/4, and 3 minus 1 leaves us with 2. There we have it, 2 3/4. Again, this might not necessarily seem easier than the system you might be familiar with, which is converting these to improper fractions first. But there's something about mental connections and numbers and numeracy that's really important to me here. So I'd like you to try and understand it this way. In fact, I'll go through one more example just so you can see the same concept with different numbers. All right, so we look at 7 1/3. Subtract 2 1/2. I should end up with the same problem here because a half is larger than a third. But first things first, we'll make our equivalent fractions. Between 3 and 2, the lowest thing that those will both multiply to be is 6. So 3 times 2, top and bottom, I multiply by 2. And a half, I have to multiply the top and bottom by 3 to get it out of 6. So there we have it. 7 2 6, subtract 2 3 6. Okay, so in this trades type of system that we're going to subtract these fractions, I try to go 2 subtract 3. I run into the same problem where I'm going to end up with a negative number. So what that means is that I need to borrow from this column, right? So 7 is going to reduce down to 6. Okay, so the 1 whole that I borrowed, I'm interested in adding 6ths, right? Because that's what my fraction is out of. So 1 whole is the same as 6 over 6. 6 divided by 6 is equal to 1. All right, so what I'm actually adding to the top of the fraction here, or adding to this fraction, is 6 6, or I basically just add 6 to the top. 2 and 6 makes 8 over 6, and 2 3 6 over here. Okay, so again, what did I do? I borrowed from 7, it came down to 6. I figured out that I was dealing in fractions out of 6. So I'm actually increasing this top number by 6 here, and that's how we got our 8 over 6 down here. So let's finish off the question. It's pretty easy now. All right, so subtract the fractions. 8 minus 3 is 5 out of 6, and 6 minus 2 is 4. There we have it, 4 and 5/6. All right, so these last two videos actually in fractions have both been fairly long and involved depending on your comfort level with fractions. There's no secret to it other than the more you practice, the better it will sink in. So I hope you can spend some time on this. Struggling with it is normal and actually really helpful. What you'll find is it'll probably be a struggle at the beginning, then you'll start to get the hang of it. It'll seem a bit easier, and then a little ways down the road it will feel automatic and you barely have to think about it at all. That's what we're aiming for here. Good luck.